So good evening, everybody. My name is Dominique Bachelet, and I'm an associate professor in biological and ecological engineering at OSU. And I've been a climate change scientist since 1989. In the last decade or so, I have focused my energy not only on creating content, but also on designing a variety of communication tools to share climate change information. This year, it's my great pleasure to announce that the Corvallis Arts Center has generously chosen to host an art show this fall dedicated to climate change under the title, What Will Nature Do? The public media has been very effective at inflating the importance of climate deniers and at focusing on the worst negative aspects of the projected changes. The writing of these journalists has been found to cause denial, numbing, apathy, and more importantly, despair and hopelessness among the young. Today, we know that climate change is here, and we've seen the youth of the world rising and demanding action to limit the negative impacts on their generation. There are many ways to envision the future, and as a modeler, I have spent quite a bit of time simulating transitions towards a world adapted to warmer conditions. Given the inertia that has followed the thousands of publications, reports, and congressional hearings, I find it essential to diversify our approach to envision the future if we want to reach a broader audience. My optimistic view.
People need to mute if they're not Dominique.
Yeah.
And Dominique, if you have two sound sources in your environment, you need to mute one of them.
I do not.
Okay, and you're clean.
I only have it. Okay. So my optimistic view is that climate change was caused by us, humans, thus we can do something about it. Many colleagues have talked about solutions and identified low-hanging fruits to get there. I'm hoping that through this series of lectures by scientists who are experts in their field, artists are inspired to give us their vision of what might happen when we get people engaged in working together in the spirit of responsibility and solidarity to fix the most egregious problem we've created. Today, it's my great pleasure to introduce the first of our science speakers, whom I have tasked to inspire artists by showing us how ecosystems do function to survive adversity through adaptation and evolution. So Steve Wondzell is our first speaker, a research ecologist for the US Forest Service Pacific Northwest Research Station. He's received his master's degree from New Mexico State University, and he has continued to monitor the study plots he had as a grad student. Echo again. And has now a 60+ year record of plant dynamics at Big Bend National Park, Texas. His love from deserts and sunshine somehow got sidetracked, and he ended up studying stream groundwater interactions in old growth forest streams for his PhD in Oregon. He studies how water and the shape of the riverbeds are influencing stream ecosystem processes, especially stream temperature and carbon and nitrogen cycle. He also studies the effects of forest harvest and stream buffer designs on stream temperature, the influence of climate change and channel restoration on stream temperatures, and the influence of browsing by deer and elk on restoration of streamside hardwoods in the Intermountain West. So without further ado, Steve, take it away. Okay.
So Dominique, you probably have to mute your computer. I think some of the feedback you were getting was from my microphone.
I don't
so
think so.
For those of you who don't know, Dominique and I are a couple. We're at opposite ends of the house, but I guess the house isn't quite big enough. It also explains why I'm coerced into speaking to you all tonight as your first speaker. But actually it is fun to have an opportunity to talk to you about some of the research that I've been doing. In this case, I'll talk about the work. Come on, jump to full screen. There we go. About the work I've been doing in Eastern Oregon in examining ways that we can restore streamside forests to cool streams and make them more habitable for salmon in the future as the climate continues to warm. So part of my work involved building a model to try and simulate vegetation dynamics along the stream sides. And to build those models, we wanted to make them not only predict the future vegetation, but the past vegetation. To build a model like that, we have to have an idea of what the world looks like. When we're involved in restoration, we simply have to face this question. This little cartoon here, right? There's a bird and a fish, and they have different opinions about how the stream should be modified to make it better for them. And so as a scientist, if we think about restoring the world to make it better for some particular goal, we are immediately faced with this question about, well, what should the world look like? How can we do this restoration so that it meets the goals that we're interested in? That's a really tough question to answer. So scientists often sidestep that. And instead of saying what the world should look like, they ask the question, well, what did the world used to look like? And can we make our restoration follow a template of what it used to look like? So at the beginning of this research project, a collaborator and my postdoc and I stood on this bridge in Eastern Oregon. And the two views, the left-hand view is looking upstream from the bridge, and the right-hand view is looking downstream from the bridge. And we stood there saying, well, what should this stream look like? It looks quite different on different sides of the bridge. And we were certain that the downstream view has been affected a lot by human beings in some way. The channel's too straight. There's a little bit of erosion on the edges. We can see cows in the background. But what should it look like was the question that we faced. So I would argue that as you try and answer that question, it's heavily influenced by your understanding of a place's history, a place's context. I suspect that all of you as artists, when you go to paint a picture, take a photograph, make something, you don't just, if you're painting a picture, you don't just paint what you see, you paint an interpretation of what you see, an interpretation of what you think the world should look like, one that's based on the thing you're looking at, but it's also heavily influenced by your own context and your own worldview. So the next picture I'm going to show you, I think you should be able to see my cursor. It's a red pointer. The next picture I'm going to show you is taken up here on this ridge at the far side of this meadow, and it's looking back towards the bridge, okay? So here's this white arrow in the middle of the screen is the bridge over the stream. This is that same meadow in the 1950s. This is a place that used to be Bates, Oregon. You can see the stream that today flows straight across this meadow. In the 1950s was pushed up to the edge of the valley floor, and it wrapped around here and it went to a sawmill. This is a mill town for a small mill that was located in the headwaters of the Middle Fork of the John Day River. If we go back to that original picture now, our understanding of that place has changed dramatically. We now know something about its history. And knowing that history influences how we interpret place. So what I want to do for the first part of my talk is to take you on a little history trip. And that history trip is going to be about this place. And so here's a Google image of the greater Northwest, and the big yellow circle in the lower part of the image is the place. The blue line outlines basically the Middle Fork of the John Day River. The John Day River is a tributary to the Columbia River, which is the big line that squiggles through the graph or through the picture. And you can see the star over here towards the left, and that's where we are in Corvallis, Oregon. So we're going to be taking a historical trip, kind of thinking about the things that have happened to the Middle Fork John Day River over time. And that trip is going to take us back 200 years. Okay, we're going to start from tonight, the Corvallis Art Center's What Will Nature Do discussion here in 2021. And we're going to go all the way back to the time of Lewis and Clark. This kind of follows the trajectory I went on my project as we tried to understand what our models should simulate in our landscape. So I'm going to go through kind of the steps that we went through trying to see if we could figure out what our stream should look like. I'd like to note here for our history trip that the Columbia River was, quote, discovered, so discovered by Western Europeans in 1792. And only a few years later, Lewis and Clark spent the winter of 1805, 1806 at the mouth of the Columbia River. And then Fort Astoria was built in 1811. So we're going back a little over 200 years. So in my project, the very first thing we thought of, well, we can get an idea of what these streams used to look like would be turning to aerial photographs. So the top image is an aerial photograph taken in 2005 of a portion of the Middle Fork John Day. And you can see that this river is pushed right to the valley wall. And you can see the trace of one of the old channels, this green line that wraps through the valley. And if you look at the aerial photograph taken in 1940, you can pick out the line of the river. It follows that green line we see above. And you can also see abundant trees growing on the valley floor. Whereas by 2005, the valley floor is mostly grass. This was an intentional change. These are the kinds of things that we have done in the past to make the world better for us. This kind of a photograph shown here, this is not on the Middle Fork John Day. It's a nearby river in the Starkey Experimental Forest. It was taken in 1952. And this is a range improvement project. By removing shrubs and trees from the valley floors, those areas would become more productive of grass and therefore provide more forage for livestock and become more productive. And these are the kinds of photographs that might have been featured in an annual report that was put together in 1952 that was describing the successful work that the Forest Service was doing to improve the world. This is one of the themes that I'd like people to come away from my talk with, is that when we look back at pictures like that today, we do, at least I do so quite judgmentally, saying like, wow, this is a really negative ecological impact. But people in 1952 saw the world differently. And this was seen as a positive thing, a thing to make the world better. And most of the changes I'm going to be talking about on this historical trip were things that were being done through time to make the world better for us, for you and me today. And in many ways, those things have been incredibly successful. Okay, so that takes us to 1952. Aerial photographs only go back to about the time of World War II. So we have to turn to other records. And Bob Wismar was a professor at University of Washington. He wrote a paper in 1994, and he looked at some of these things. So I pulled numbers out of his paper and graphed them here. And this is a graph of the logging volumes from Eastern Oregon from 1920 through about 1990. So you can see that logging, actually, we know something about it. It started in the late 1800s. In fact, the Sumter Valley Railroad was incorporated in 1890. This was located in Baker City, Oregon. The railroad was pushed up the Sumter Valley, eventually crossing the divide, dropping down into the John Day River, and in the early 1900s began logging in the John Day River system. The railroad followed the valley floors, so the logging was concentrated along the valley floors. So we see that these landscapes, that photograph we looked at of Clear Creek from the bridge, those areas have, the railroad goes right through there, the old railroad bed, and that area has been logged starting in the late 1800s. Another thing was livestock grazing. Livestock grazing began in Eastern Oregon in about the 1860s. We don't have good data until the early 1900s, starting in 1910, when the Forest Service began monitoring grazing rights on the national forest lands. You can see that there were incredible numbers of cattle on the rangelands around the turn of the last century. And through time, the number of livestock on those rangelands have declined. The grazing livestock, of course, have large impacts on the landscape and strongly influence the areas around streams. The cows in the summertime like to hang out in the streams and eat the grass there, and cause a whole host of problems. And the incredible number of livestock that were on the rangelands back in the late 1800s and early 1900s created really severe problems. And then there's mining. Okay, so mining also started sometime around the 1850s, 1860s. A lot of it started, as you see here on the left, this idea of the old prospector that takes his gold pan and heads for the hills. But by the early to mid 1900s, mining had changed considerably. There was extensive dredge mining. So the photo in the upper right is a large dredge that's kind of thing that was operating both in the Middle Fork John Day and along the Powder River, the Sumter Valley dredge. And in fact, there is a state historic area, heritage area located in the Sumter Valley where not only the effects of the dredging are preserved, but so is the dredge, and you can go and visit that. So all of these things had big impacts on the streams through time, making it really difficult to walk out to those streams now and guess, well, what should those streams look like? Well, an interesting thing happened when the lands of the Northwest were being surveyed and being brought into the United States, essentially, that the government land office had people go out and mark off the land in square mile increments. This was the system that we use in the United States for surveying land. We have ranges and townships and section lines. A township is 6 miles on a side, so it's 36 square miles. Each of the square mile parcels inside of there, there's 36 of them inside of there. And what they would do in the Territorial Survey was send out surveyors to walk the lines between each of those sections across all of Oregon, from east to west, north to south. And at every corner of a square mile, they would either blaze a tree or build a rock cairn. And they would take notes then about what they found along that 1 mile length of land that they surveyed. So in the Middle Fork John Day, the Territorial Survey was done in 1881. Though all of those records are online today in a BLM office. You can go online and look them up, find the place you're interested in. And so this is a section of a portion of the Middle Fork John Day River that was surveyed. And the dark black line at the top shows the 1 mile length that is being described. And I zoomed in to show the description, and then I translated it, make it easier to read below. And it said, the surveyors found in 1881, they found timber, heavy pine, fir, tamarack, which is western larch, if you know that tree, with thick growth of willows on the river bottom. And the length of their section line was 71.52 chains. They surveyed by pulling a chain, which was 66 feet long, and drug it in a straight line and measured the length of the, as they surveyed along these 1 mile lengths. So we have this series of descriptions from 1881. And I looked up all the descriptions for the upper Middle Fork John Day that were online. And the black bits on the map shown there are these different descriptions from the surveyors, which I've translated down below. And what I was amazed to see that in 1881 was the description for the surveyed line marked number 8, Graham's Field. In 1881, the Middle Fork of the John Day had a fenced and plowed field located in the valley floor. I had thought 1881, it's so early. Yes, I know there's been some kind of human influence here, but it's at the beginning of the grazing, it's the beginning of the mining. That influence ought to be small, and these records ought to provide us a good idea of what our world should look like. And here I find in those notes evidence that the land is already being plowed. Well, this is why immigration to Oregon via the Oregon Trail peaked in 1852, with 10,000 people coming across the Western United States in covered wagons. Most of those people went to the Willamette Valley, but some number of them settled elsewhere in the state. Remember that we had mining already by the 1860s. The miners weren't interested in farming and growing their own food, but they needed to eat. So the early grazing and probably early farming, right, found a ready market for other people like miners living on the landscape. You can see that after 1852, the immigration via the Oregon Trail drops off quite radically. That's because gold was discovered in California and people started going to California instead of Oregon. So what happened before 1852? Well, beaver trapping. This is something you've probably heard about. In the upper left is a photograph of what was a beaver hat. A top hat was the rage in England in the early 1800s. And this was made from felted beaver fur. The actual hair of the beaver were shaved off of the skin, and the hair was matted together to form a felt, and the felt was used to make these hats. I had always thought that beaver trapping had finally maybe gotten rid of beaver sometime in the 1860s, but as I began looking into this story of the history, I just discovered something quite a bit different. Remember I said earlier that the Columbia River was discovered by Western Europeans in 1792. Lewis and Clark spent the winter of 1805 in Astoria, 1805, 1806. By 1825, beaver were mostly trapped out of the Willamette Valley. So many of the people that are listening to the talk tonight live here in Western Oregon, live in the Willamette Valley. Next time you go somewhere in your car and you get out into the valley, take a mental pause at least and look across the landscape you see and just think that beaver have been missing from our valley for over 200 years now. We really don't know what the Willamette River Valley used to look like when it was full of beaver, full of marshes and swamps and ponds, full of oaks and forests and savannas, something completely different than we have today. But those changes not recent, those changes started 200 years ago. Only a few scant years after Lewis and Clark spent the winter here, a few scant years after the place was discovered by Western Europeans, by Euro-Americans, beaver were trapped to extinction. There's an interesting side note of history about this. In 1823, the Hudson Bay Company formulated what it called its fur desert policy. So in the early 1800s, the border, the frontier between Great Britain, what is now Canada, and the United States had not yet been determined. The Hudson Bay Company thought that the border would most likely follow the course of the Columbia River, and they wanted to protect their trapping monopoly on beaver. They were facing competition from Euro-Americans that were coming west and trapping. That was the biggest, in the early 1800s, the biggest immigration to Oregon were beaver trappers. So they actually formulated a policy to trap a beaver to extinction in all locations to the south and the east of the Columbia River, thereby making it unprofitable to come here and trap, stopping immigration, and furthering their case for the Columbia River being the future boundary between Canada and the United States. So this was a matter of international policy in 1823 to trap beaver to extinction. So this is going to be the end of our history trip. There's lots of other things we could talk about. Climate has not been stable. Even over recent history, there was something called the Little Ice Age, where temperatures were colder than they are today, which ended around 1850. In this graphic, I show that the influence of Native Americans stopped about 1855. That was when the tribes, the Wascos and the Warm Spring tribes, signed the Treaty of 1855. They ceded 10 million acres of their land to the United States government and were relocated to the Warm Springs Reservation. If we look forward in time, there's things like road building. Railroad logging dominated up to about the time of World War II. After World War II, we had the technology to build big logging trucks, and it opened up large portions of the landscape to logging once we built the road so the trucks could get in there. The Forest Service has been busy doing fire suppression since 1900, and that's had big changes in the compositions of our forest over time. So that's our history trip. But remember where we started. So look at this picture again and think about this place. Some of the things we talked about logging. As I said earlier, the railroad bed of the Sumter Valley Railroad runs through the background of this photograph. It's a National Historic Landmark. When the Forest Service wants to do restoration in this valley, one of the things they have to consider is how they work around a National Historic Landmark, which is a 100-year-old railroad grade. We saw that this used to be a mill town that's been removed. We saw dredge mining just a little around the corner and downstream to the left. There's dredge mining, mine tailings that are going on. So all of those things, beaver were trapped out of this landscape almost 200 years ago. So all of those things that I talked about have impacted this place. And if we ask the question, what should this place look like? We're really left, I think, in a place where we can't answer, a question that we can't answer. History has had too great an impact. The changes have been so great. And now we add on to that concerns of climate change, that the future isn't what it used to be, that somehow our climate is changing. So whatever this place used to be is not something that it can be in our futures. Okay, so we have to make a little shift here. How do I do this? Yes. So why is knowing this history important? It's important because we're facing environmental challenges today. And in response to those challenges, one of the things that we are thinking about is trying to restore our ecosystems. If we think just about salmon in the Columbia River Basin, fisheries biologists talk about the 4 H's, that salmon populations have been impacted by impacts to their habitat, direct impact from harvest of fish, by hydroelectric plants that block fish passage up and down rivers, and by genetic effects that stem from growing large portions of the fish populations today in hatcheries. So those are the 4 H's: habitat, harvest, hydro, and hatcheries. We're going to talk about habitat. So this is just a couple of pictures of what the commercial fishing used to be able to do at the mouth of the Columbia River, lower Columbia River. And this is the kind of thing that was being produced. Cannery production on the lower Columbia River peaked in the late 1800s, maybe as early as the 1867 to 1910, somewhere in there. All of those cans there, that's the storage room. That's what it says at the bottom, storage room in a salmon cannery. So this is on the Columbia River. So the top graph shows in the dark solid line is the Chinook harvest from 1900 to 2010. And the harvest is the y-axis, the upright axis on the left, is the number of fish in millions. So you can see in 1910, the commercial Chinook harvest was about 1.8 million fish. The dotted line is the hatchery production. And the numbers for the hatchery production are on the right-hand side in millions also. So you can see that, for example, in about 1995, 160 million juvenile Chinook were released into the Columbia River system. Hatchery production started in the early 1900s. And the commercial fishery has been declining since the early 1900s until it's really, really tiny today. The lower graph shows more recent. It goes from 1940 to again to 2010. And it shows the salmon abundance in the Columbia River system. The big gray portion at the top gives the approximate abundance of salmon, say in the early 1800s, before Euro-American influences on these runs. Best estimates are that the number of salmon swimming upstream on the Columbia River was somewhere between 8 and 16 million fish each and every year. That's another thing that we have no idea what that would look like. That hasn't happened in any of our lifetimes. Today, runs of all salmon seldom get more than 2 million fish a year. That's Chinook, coho, sockeye, and steelhead combined, all salmon and steelhead. Rarely get above 2 million fish a year. So those bars on the bottom show the commercial harvest, which you can see is now tiny, and then something that's called escapement by fisheries biologists. Those are the fish that return to the river and escape the commercial harvest and actually manage to make it to their spawning grounds. And that big black dotted line there, or dashed line, is the recovery goal that's set by the Northwest Power and Conservation Council. Their hope is that through restoration, we can rebuild the runs on the Columbia River so that each and every year we're seeing around 5 million fish swim upstream. To get there, the Bonneville Power Authority has been funding one of the world's largest restoration projects. This is larger than the efforts that have been going into the Florida Everglades, larger than been going into restoring the Chesapeake Bay system. It is simply one of the biggest restoration efforts anywhere in the world. This slide is a little bit dated, so these numbers are, say, 10 years old. But 10 years ago, the Northwest Power and Conservation Council and Bonneville Power Administration were investing about $300 million a year into restoration projects. And in the 1980s, they had already completed something like 13,000 habitat projects, or sorry, since the 1980s, they had completed 13,000 habitat projects. So these projects are designed to try and address the biggest environmental problems that the salmon face. And for the upper Middle Fork John Day, one of the biggest problems is water temperature. So this is a photograph that was taken by Jim Ruzicki from the Oregon Department of Fish and Wildlife in 2013. The graph shows the water temperatures on the Middle Fork John Day in June and July. You can see they it's each individual day, it's hot in the middle of the day, it cools off at night, okay? The black line is 2013, the blue line is 2007. The water temperatures are in degrees Fahrenheit ranging from 46 degrees to 82 degrees. The solid line at 75 degrees is a maximum lethal threshold of temperature for salmon. And you can see that in both 2013 and 2007, this water temperatures exceeded this threshold. In 2013, Oregon Department of Fish and Wildlife estimated that 60% of the spring Chinook died before they had a chance to spawn. In those few days when the temperatures skyrocketed, climbing into 82 degrees water temperature, 60% of the fish died. These fish are really amazing. They swim upstream in the late spring and early summer when flows are really high. They navigate their way over the dams on the main stem Columbia, up the John Day River, up into the small tributaries like the upper Middle Fork. They arrive there sometime in early to midsummer, and then they stay in the river. Once they leave salt water, they don't eat. They swim hundreds of miles on their body reserves of fat. And once they get to the upper Middle Fork John Day, they find deep pools and they just stay in the river and wait until early fall before they spawn. So water temperature is a huge stress for these fish as they sit in the river waiting for a chance to spawn. And if they die, it has huge impacts on the productivity of salmon in the future. So this is a little graphic of a heat budget of a stream on a summer's day, much like the Middle Fork John Day River, with all the different fluxes of energy into and out of the stream. So we all know that if we get wet and on a hot summer day and stand in the breeze, it cools us off really quickly. So that's called evaporative cooling. And when water evaporates from the surface of a stream, it cools the stream. We don't usually think about it, but when water condenses, it's the opposite of evaporation. So if evaporation cools, when water condenses, it actually heats things. So if water condenses onto the surface of the stream, it will actually heat the stream. You can see my arrow is kind of small. The sizes of these arrows here kind of give you a rough idea of how important this is into the heat budget of the stream. Convection, I called here, is a lot of hot air. Okay, this is just wind blowing across the surface. So it can also be a lot of cold air. When you have a soup spoon of really hot soup and it's too hot to eat, and you blow on it to cool it off, that's convection. You're cooling it off because your breath is cooler than the soup. If the air is really hot, and as we look at climate change and think of the air getting hotter in the future, we might expect that the air will tend to warm the stream, and that would be called convection. Long wave is a complicated one. It also has really big arrows, but you can see that the two arrows go opposite directions and they're almost the same size. So the effect of long wave can be important at times, but on a summer's day that tends to cancel it out. And because it's complex, I'm not going to talk about it anymore, okay? Conduction is why you need a hot pad. If you take your pan off the stove and set it on a stone countertop, it gets cold really quickly. That's because the heat is conducted from the bottom of the pan into the stone. So if you put a hot pad there, you keep it hot longer. Okay, the groundwater and hyporeic, you can just think of those things on a summer day as adding cold water to cool the stream. So the elephant in the room, the biggest thing there is that big, bright yellow arrow. Okay, direct solar radiation shining on streams is a huge impact on, or can have a big impact on stream temperature. How big an impact it has is a little bit dependent on the size of the stream. You know, think about putting a giant pot of several gallons of water on your stove when you're going to can jam. It takes a really long time to bring it to a boil. If you put a tiny little pan on the exact same burner, it'll come to a boil in a few minutes. So how big the stream is and the size of these energy terms that are either heating or cooling the stream will determine how much its temperature changes. We're only going to talk about two today. We're going to talk about hot air, because with global change, we expect hot air to change. And we're going to talk about direct solar radiation. So here's convection, a lot of hot air. And we built a model of the Middle Fork John Day, and we changed the air temperature. And these are the results. So I'm skipping over building the model and all kinds of details. I thought probably not be of great interest and would make the talk really long and would really make Dominique and I have dinner late tonight. But this is the results. Okay, so the black line there shows the base case of the model. So we started our model to simulate the stream temperatures in 2002. And then we took all of the data we had for our model, and the only thing we changed was the air temperature. We increased the air temperature by 7 degrees Fahrenheit, which is the projection for the global climate change projection for change in air temperature maybe 40 years into the future. And we reran our model. And you can see here the differences in water, in the stream water temperature from my base case to the hot air case. And what you see basically is increasing the air temperature by about 7 degrees Fahrenheit increases the water temperature maybe by, say, 2 degrees Fahrenheit. It definitely has an effect. But an effect, as you'll see, actually is kind of small. The dashed blue line in there is a regulatory threshold set by the state of Oregon for it's a cold water criterion for streams with cold water dependent fish like salmon. So when the temperatures are above that line, the stream is seen as out of compliance, and the state is required to develop a management plan to try and reduce the stream temperatures. So you can see that the Middle Fork John Day today is out of compliance with this threshold. Okay, so we're going to compare this future air temperature increase to what happens with shade and solar radiation. And just keep in mind here that 7 degrees Fahrenheit increase in air temperature gives you about a 2-degree increase in stream temperature. So remember, this is our biggest arrow, so you'd expect it ought to have the biggest impact. And what we're going to compare in our model are 4 different kinds of vegetation. We don't have a rheostat to change how brightly the sun shines. So instead, what we can do is manage the streamside vegetation to provide shade to the stream. You can see the upper left picture is the current shade at about 19%. And we then compared the current condition to what we might expect after a wildfire when there's 7% shade, with 2 restoration scenarios. One is when the forest is relatively young, with 34% shade, and then when we have time to grow a mature forest with 79% shade. And here are those results. You can see that the black line is still the base case, and you can see that the post-wildfire situation doesn't change things very much. The change is not dissimilar to what we see from a 7 degree air temperature increase. That's because there's not very much shade, and removing the little bit of shade we have doesn't do a lot. The young forest adds a little bit of shade, so it actually cools the temperatures a little bit, and it's in the order of 2 to 3 degrees. But what's really amazing is what the mature riparian forest does. It cools the stream by a lot. It's that dark green line, and it brings the stream for this period of time below, for lots of that, below that dashed blue line. So this is an amazing change. By managing the forest along the banks of the stream, we can have a much bigger impact on the stream temperature than climate change is going to have in the future. And in our model, we compared the same mature riparian forest with the future warmer air, and this result is robust. The future stream temperature can be colder than it is today, even when the air temperatures are 7 degrees warmer than today, if we have those mature riparian forests growing along the stream. Now, if you think back to our history trip, there's another important point to make here. These changes in vegetation that we are seeing here reflect 2 centuries of land use change in the Middle Fork John Day. Middle Fork John Day used to be much more heavily shaded than it is today. It may not have been as shaded as our mature riparian forest scenario, but it was much more heavily shaded. And 200 years of land use, making the world better for us, has created a system where shade is relatively uncommon, and the current water temperatures are really warm. With global change, they're going to get even worse. But global change isn't the biggest driver of these effects. The biggest driver so far has been land use. Well, if it's been land use, then restoration has a chance to reverse those factors. So in our model, the trees we decided to simulate for our mature forests were ponderosa pines that were 100 feet tall. And I had done all this model work and all the simulations and published the paper. And only after that did I pause and think, well, how long does it take to grow a tree? It turns out in the cold and dry Eastern Oregon, growing a ponderosa pine tree takes a long time. To grow at 100 feet tall tree, this is Forest Service data that was provided by Andy Gray from the Forest Inventory and Analysis Program. These are actual data plots for ponderosa pine trees that are growing within 100 feet of water. And the line fit to the data point suggests that on average, it'll take around 130 to 140 years to grow a tree 100 feet tall, the tree that we put in our model. That was a little bit sobering, okay? Remember, we went on our history trip. This is a reminder, you know what all of these lines and squiggles and shades, etc. Well, we're gonna compress this and try and look at put the future in this context. The first thing is you notice that there's this big gap over here from 1990 to 2020. That's because Bob Wismar published his paper in 1994, and I don't have any data. It'd be nice to update the data. But it also turns out that that 30-year period is not a bad match for my career in the Forest Service. And I'm really interested, and the people I work with are really committed public service servants that are interested in trying to restore the world and make it better, but make it better. We need trees, we need meat from cattle, we need these things, but we also want to have salmon and rivers in our futures. And this is a group of committed public servants that are trying to do that with the lands that they manage across Oregon, across the Western United States. Well, take their careers and put it in the context of 200 years of history, and you realize the incredible amount of work that it takes. If you put those people to work planting trees today, this is what it looks like. It's a long time in the future before we get 100-foot tall trees. It's at the same scale as the last 200 years of history as we move forward. This is sobering. I think there's a couple important messages. We have to remember that we have 200 years of Euro-American history in these places, and we can't reverse that history overnight. We can work towards making the world better, but when we think about our politicians, they want to claim success quickly. As individuals, we are not patient. We don't want to start projects that are going to take 200 years to have a result. When you start your painting or start a sculpture, you're not thinking that, oh good, this will be done 200 years from now. My woodworking projects will probably be done in 200 years, but hopefully not your paintings. The other thing that's important here is that for many of our streams, we don't need 100-foot tall trees to shade them effectively. We can also plant species that grow more quickly. But we have to face the future as we look at climate change, as we look at the other kinds of environmental issues we face. We have to face them with some realism about the magnitude of those those problems and how quickly the world can be changed. In this case, it simply takes time to grow trees, and you can't make the trees grow faster. Okay, just some final thoughts. So I was trying to say is basically climate change is just another stressor. For the moment, at least, land use has likely had a much bigger impact than climate change has. There are real reasons to be concerned for worst case scenarios of climate change in the not immediate future, but grandchildren's future, that it can get really bad. We have a lot of opportunity by trying to restore the land from its historic uses. That can really have big changes in the future. We have to be patient as we think forward. And finally, the Chinese proverb that the best time to plant a tree was 20 years ago, and the second best time is now. So thank you all for listening. And of course, thanks to all the different folks that make my work possible. This work itself was funded by the Forest Service and the USGS for climate change impacts and stream temperature, Oregon Watershed Enhancement Board, and the Confederated Tribes of the Warm Spring. And all of the model results on stream temperature that I showed you was the work of Musa Diabat, who did his PhD with myself and Roy Haggerty here at Oregon State University, and is still working in environmental things here in Corvallis. So thank you very much.
Thank you, Steve. So if people have questions, they can put them in the chat and I will read them to Steve. But I will start the question with a few that I had ahead of time when I talked to Hester yesterday. So Steve, how important do you feel it is for lay people to know about your research?
So both very important and not important at all, okay? What's important? What is important is that people have enough context to understand what they hear or read in the news, that they can think critically, that misleading statements don't become accepted as, oh yes, we can do this, or think about all the things about wearing a mask in society today, where people don't want to pay attention to what virologists and doctors are telling you. They say wear a mask. So it's important to have context and some general understanding so that we can interpret the world around us and make good decisions. But knowing the details of all of this stuff, I don't think itself is important unless people are really interested in it. I think it's really fun to talk about it, and I think hopefully enough of what I said is interesting to the people that were listening, that you get something out of it. But yeah, I think the science is important, but knowing the details of this is simply too much to ask of people. But having some basic science understanding and being a critical thinker when we hear articles in the news and be able to understand them, I think is really important.
Okay, my second question is, how do you usually go about communicating your research results?
So a lot of what we do is talking to other scientists. What I gave here was some slides from a number of presentations that I've made to scientists or managers. We write this stuff up, and I think Dominique may have included a publication in the announcement of this. We write papers that are specifically for scientists. We probably don't do enough of things like tonight's presentation, where we get to talk to a broader segment of the interested public. It's a fun thing to do, but maybe as scientists, we're not very good at seeking out these opportunities, and they don't land in our laps all that often.
Okay, so John Selker has a couple of questions for you, talking about scientists. The air-water area also controls energy. Don't the processes that narrow the channel occur faster than the shading?
They could. Right, so John, if you don't know him, is a professor at Oregon State University, and he's also been working at the Middle Fork John Day, working on stream temperature. And so there are lots and lots of things that can influence the stream temperature and how it responds to things like sunshine. And one of the big factors, as John is pointing out, is how much of the surface of the stream is exposed to the sun. So there's you can shade the surface of the stream, but if you made the stream narrower and deeper, you would have less surface area and it would get less sun. It's possible that channels can narrow. It hasn't been super well, that's not right. This has been studied a lot, but the answers are not particularly clear. The Forest Service, for example, has set up lots of exclosures where they fence a portion of the stream and the streamside vegetation from cattle and deer and elk and beaver and things like that, and then just wait and see what happens. And in some cases, the channels narrow quickly, in other cases, they don't. So it's not, short of some active intervention, and this has been done extensively actually on the Middle Fork John Day, where the channel is actually rerouted with a bulldozer and reshaped. And in those cases, you can have a quick and big effect on the amount of water that's exposed to the sun. But just from passive restoration, where we just take away the things that are having an impact, like grazers, and wait for something to happen, that may or may not happen, or it might happen really slowly.
So Cynthia asks you, it's like, what other species are being considered in these projects? She loved your drawing with the basic interest involved with thinking about best interest between fish and birds.
Salmon, Chinook salmon and bull trout are the primary species of interest. I don't think Chinook salmon, so the Endangered Species Act, I think bull trout are listed as threatened. I don't believe the salmon are. These are kind of seen as indicator species, that if we can make the world better for these cold water dependent fishes, that will be doing a service to many other species that are also dependent on our streamside ecosystems. As far as I know, the funding, yes, so that's right. So the funding for these projects comes from the Bonneville Power Administration. The reason that, I'm sorry that the sun has gone down and I'm now sitting here in the dark, so I'm just a dark shadow. But
you need to turn on your lights, do you?
It's a backlight, unfortunately. I don't know that it'll help.
Well,
I'll go away in a second and try something. But the funding for these projects also comes from the Bonneville Power Administration, and it's Bonneville, the hydropower dams in the Columbia River have had a big impact on the size of the salmon runs. And so they fund these projects as a way to mitigate their influences on salmon, so that the funding itself is directed towards salmon recovery and not to other species. I'll try turning on some lights. I can hear while I'm away from my computer, so. Okay.
So you said essentially that land use decisions are driven by the current values of the people who have control of the land, which may be individuals or communities of varying sizes. What is your evaluation of the possibility of changing community values, which might push toward more beneficial land use decisions, which could drive interventions, which would help solve temperature problems?
Let's see. Can you read the first part of that again?
Yeah, you said essentially that land use decisions are driven by the current values of the people who have control of the land.
Okay, stop. So I didn't know that I said that. I suppose that might be true.
You didn't. It was what I presumed you meant.
Okay, great. I do think, though, I think the question gets on something that is, in fact, really important. And I did kind of imply, right, that I showed that picture of the bulldozer from 1952, that this was seen as a positive thing, right, that was improving the world for us. The fact that the Forest Service would show that and identify it as an issue, I think, is indicative of the degree of cultural change that has already occurred. We have undergone incredible cultural changes in cultural values. And those are part of what is making it possible for such extensive interest in restoration in these places. Those things remain controversial because, you know, for example, I believe the Forest Service was taken to court about the status of the streamside vegetation throughout the Malheur National Forest. The Middle Fork John Day is on the Malheur. The environmental group that took the Forest Service to court won an injunction against grazing that required ranchers to take their cows off the streamside areas. And that has a huge impact on ranchers' livelihoods. Right? You're not just talking about some grass and a couple of fish. You know, you're talking about whether someone makes their mortgage payment next month. So those kinds of legal controversies have not helped in many ways, have not helped. I mean, sometimes they're necessary as a catalyst that forces change, but the Forest Service today is trying to find ways to work with groups that have different values and get them to work together and come to a kind of collegial agreements about the land, how the land should be managed. And they're doing this through a system of collaboratives. And the Blue Mountain Forest Collaborative is one that covers the Middle Fork John Day. I've been invited a couple of times to speak to them as the collaborative themselves tries to grapple with these kinds of science and management and cultural issues. There was even an Oregon Field Guide episode, and I think it was actually, it might have been the Blue Mountain Forest Collaborative, but it was one of the collaboratives that was on the Field Guide episode, you know, and after many years of people finding it hard to work together, but spending time together, they began to find out that they had a lot in common. And that the Oregon Field Guide episode is a really interesting watch because it brings people with what from the surface often seem like really strongly different values and culture, but underlying, you know, ranchers are fundamentally motivated by the health of the land around them, and they don't want to do things that destroy the health of their land for their children and their grandchildren. And if you fish or if you hike, you know, you share those sentiments. And so it's a super complex thing that's been fought out in the court sometimes, and maybe more productively, more recently through ways of trying to figure out for people to talk and share and build a kind of collaborative management arrangement.
So there were several questions about, are there other species, you know, that grow faster than 100 years? Can you do a mixture of trees? And do your models actually, and you know, take into account how much the shade is increasing as the trees are growing?
So we have different kinds of models. The stream temperature model is maybe gets clunky. And so we have to specify our future vegetation. And so we only specified the vegetation that I described. We didn't do anything, didn't try other scenarios. And we could do that and try and get a better handle on what we need. I think the more interesting part of that question, and I could make the talk really long. I took out a large section. The tribes purchased two what had been private ranch lands in the Middle Fork John Day and have set about substantial restoration projects, which have led to them planting. They have I think they have about 7 miles of, in 2 different parcels, a total of 7 miles of river. And along those 7 miles of river, they planted 85,000 seedlings and saplings of native streamside vegetation, the willows and cottonwoods and ponderosa pine and alder and hawthorn and lots of things. And one of the things I did when I was working there was to try and monitor these things. And basically, they also fence their properties to keep all cattle out, because cows are identified as a major impact on the vegetation as well as its restoration. And they expected that these plants would grow and provide shade. And after 3 years, they hadn't grown an inch. And the reason was because elk and deer hopped the fence and were eating them. Things like aspen and cottonwood would grow much faster. They could provide a lot of shade much more quickly, but the only way you're going to get them to grow initially is to do something about deer and elk. And then once they get a little bit bigger, you have to do something about beaver. And it turns out in this study of this restoration, alders and ponderosa pine trees were the only things that were escaping the deer, elk, and beaver. And so the alders don't grow very tall. So that's why we focused on the ponderosa pine in the temperature modeling study.
Julia is asking, could soil analysis tell us something about the historical path of a stream?
Yes, definitely. It may not even have to be very, I don't know, very fancy soil analysis. I showed the one aerial picture in 2005 where you could very clearly see one of the historic paths of the Middle Fork John Day through what is today a meadow. Was a big green stripe. Maybe more importantly is that the stream moves. You know, it's a dynamic system. It doesn't just stay in one place. And this has been a problem with some kinds of restoration in the past, is that they look at the stream that's there, that's a straightened channel, and say, well, that's wrong. That's not what a stream's supposed to look like. It's supposed to be meandering and sinuous. So they build this meandering, sinuous channel, but then they don't want it to escape. They want to keep it that way so that it doesn't maybe turn back into a straight channel. And so they harden edges and they try and fix it in place. And so, yeah, it's more natural, but for streams to really function as streams, they have to be free to move. And so as we look into new forms of restoration, it tries to embody those dynamics more. So, but yes, the soils could be used to identify where streams may have been in the past.
Okay, and John also was saying that many of the restoration projects on the Middle Fork actually increase stream temperatures. Could you speak to how this can become the case?
All right, so actually John was the motivator for doing the stream temperature modeling. He's always insightful, and he really challenged the folks that were working on the Middle Fork John Day with their restoration projects. They have these nice straight channelized streams, and the water flows down the channel really quickly. It doesn't, you know, I talked earlier about how wide this, or John made me talk earlier about how wide the stream was, right? How much is exposed to sunlight. The other thing is not just how much area is exposed to sunlight, but how long does the water stay there? So if the water flows down the channel really quickly, it doesn't get heated as much if it flows really slowly. And if you make the channel narrow, deep, and straight, the water flows off really quickly and it won't heat very much. That channel may not have other attributes that are good for salmon habitat or lamprey habitat or other species, but it maybe won't warm very much. So if we go and reform the channel to these big sinuous meanders, it takes the water a lot longer to flow down the same length of valley floor, and therefore it can heat more. So the kinds of restorations that are being done that add these meander bends to the channel have to be accompanied by efforts to increase shading and To increase the shading, we need species like willows and alders and cottonwoods and aspens because they grow relatively fast. So that means we have to do something about elk, deer, beaver, and cows. So the rest, if you just pick and try and do one thing with, oh, the channel's straight, so we need to make it sinuous, that's our solution. You treat one symptom, and really the restoration has to be holistic, looking at a wide range of things and try and solve them simultaneously. And you'll have to also accept that initially, the restoration efforts may have a negative impact. We hope that the long-term effect is positive, but the short-term effect could be negative. Okay. We'll see if John gives me an A afterwards.
You can ask him. He can unmute himself. But John Friedlander was asking, so does it come down to a values battle between fisheries, loggers, and cattle interest?
Well, I guess it depends on your worldview. It can, and some kinds of organizations take very litigious views where either politically or through the courts, and try and press home whatever advantage they have. A change in politics, you change one president for another and everything gets reversed. That's really not an effective way to find solutions for the long term. And so that's what's neat, I think, about these collaboratives, these forest collaboratives, where you get the ranchers and the loggers and the fishermen and the environmentalists and the guy who owns the grocery store in John Day, and you put them all together in a room with the Forest Service, and you try and hammer out an agreement that tries to meet multiple goals, that allows the rancher to pay his mortgage, right? That allows the fishermen to go and fish on the river, right? That allows people to enjoy the place for recreation. That, I mean, we have to find ways to live together. We can't, I mean, we can just, I suppose one's attitude could be, well, I'm not going to accept any solution that's different than what the world looked like before Lewis and Clark came through the Middle Fork John Day area. We want to go back in time. But that's not, in the reality is that's never going to happen. I think there are people that are so narrow-minded, and I think there are also people that, whether commercial interests towards ranching or logging, that say, I don't want any limits on what I do, right? But these are public lands. These are lands for everybody. And we have to manage them for everybody. So it's contingent on the Forest Service to find solutions that give everybody a voice and do our best to solve these problems in ways that allow us to live together and have these multiple values in our lands. Nobody's going to get everything they want, but we can probably do something that makes it possible for us to live together.
So how do you think artists would be helping you communicating your message?
I'm trying to, sorry, I'm having a brain pause here. Dominique, what is the, what's Leah's last name?
Good question.
I forgot. Okay. It's not Wilson?
I think so.
Okay. So I think she talked to this
Wilson.
group maybe, right? So some artists make maybe this bridge between science and art much easier than others. And I recently got exposed to Leah's art. A lot of work I do is actually at the H.J. Andrews Experimental Forest, which is on the west side of the Cascades, about 50 miles east of Eugene. And she has been working there as an artist in residence. And it's been amazing to see how she sees the world and how her art actually opens new avenues for seeing the world. And I think that art could play a super important role in making a story about a place accessible to people for whom the science story is just dead. It doesn't move them, or they're not interested. So exactly how you do that, I don't know. It may take someone perhaps more creative than me, but I think art can be a really important way to share a view of a place and communicate that to people. And I think, looking for various mechanisms to communicate is really important. And so art offers a new way of communication, or another way, not a new way. We've been doing art for longer than we've been doing science, but.
Is there something you find beautiful in your research subject?
I think that I have been incredibly lucky in my career. I've worked from Texas to Alaska, projects on the Copper River Delta, Prince William Sound, seeing grizzly bears and whales, to Big Bend, Texas, seeing, peccaries under creosote bushes, fantastic landscapes. The western larches turning golden along the middle fork of the John Day in the fall. So there's immense beauty in the places I worked. I've even worked in France. I worked in a horrible little stream on a gravel bar where it was out of sight, so people would come down and use it for a bathroom. But even that place had its own kinds of beauty. So the places I've had the great fortune to work in motivate me. I find an amazing beauty in them. But I also find another kind of beauty in what I do. It's an abstract beauty of seeing, of being able to sit and look at a landscape and not just see colors and patterns, but because you've studied it for 10 or 20 or 30 years, you begin to see the connections amongst the things in that landscape and how they interact. And it's abstract because it's not, you don't see that happening in real time. But as you begin to understand how those things work and interact, it builds an entire new dimension to what you can see in a landscape. And I've had the great fortune of kind of having that light bulb go off for me when I was working on the Copper River Delta, when I was working down in southern New Mexico in the desert, where all of a sudden I could see how the landscape functioned as a thing. And that is really an amazing experience. And I think it's another way of viewing. And it's like art, I think, sees things at different levels. So you can look at a picture and it's a pretty picture, but I suspect if you're not like me, if you know something about art, you can see the history that's behind that art and how it relates to things that have gone before, and it makes it more important. Or a while back, I tried to learn to play the saxophone. This is a better analogy. I was dead awful. Don't pretend I'm going to pull that out and play it for you. But I had always loved jazz music, especially older jazz with lots of saxophone. And by trying to learn to play the saxophone, it gave me an incredibly new appreciation for music, what the artists were able to do with their instruments. So one that I had no understanding of before I tried. And so the same way, working for long periods of time in these places and beginning to understand how they work brings another element of beauty to them.
Okay, in about 5 minutes, can you tell us what your reasons for optimism looking forward are?
Do we have any option? I mean, right? The world is an amazing place, and it's going to continue to be an amazing place. We have some choices about how how easily we make that world an amazing place for the people we share it with. You know, there are a lot of people who, unlike us, I mean, we live privileged lives here in America, in the Pacific Northwest, where we're really little affected by climate change. We all get grumpy because we have a couple weeks of smoke this last fall, and that was a terrible tragedy for the people who lost homes and etc. But you compare that to people maybe in Bangladesh, where sea level rise or drought, etc., are forcing migrations of people by the tens of thousands. Right? We have some choices about what we want our future to look like, and we can make it better, we can make it worse, but to some degree, the world is still going to be an amazing place. And I don't know, I guess I don't have a good answer. Sorry, I'm stumbling about.
Okay, well, it is 6:24 and we said we would stop at 6:30. So I want to thank you, Steve, for preparing this presentation and answering the questions. I want to thank all the people who posted questions on the chat box. The presentation will be posted, and it is recorded, and it will be posted on the Art Center website. So thank you again to all of you for attending. And next week, Monday, it'll be a USGS scientist talking about salmon, Jason Dunham, and you'll have more stories about fish, but not more about trees around streams. So thanks again, and we hope to see you next week.
Thank you all for listening.